Ayo, welcome back to another coding session. And today I'm thinking that I want to continue on from the last session. I haven't really touched anything outside, so we still have this. Oh, there we go. This program, which we created using the Clay framework, which, to remind you, is a UI layout library for C and or also other languages through bindings. I think that actually I read today that Odin lang got some bindings. Odin language. Ugh. Odin, this language I read on X that they managed to, someone in the community created bindings to this language as well, which is cool, but I think we're going to continue on with C for now, although it would be cool to try sometime in the future with Odin, I guess, since Odin is basically just a better version of C. Actually, let's see if we can find the bindings for Odin, because if we can find them, then let's see. I'm in the Discord for no, let's see if someone has mentioned Clay. Let's see. Okay, so there's this video, and I think, from my understanding, that he mentioned. I guess not. Yeah, whatever. Maybe they're not out yet. As far as I can tell, let's see. Odin. There's this issue. Odin, clay.rectangle. I'm running clay with Odin through web GPU, 2 targets. Hello, thanks for reaching out. I've seen a bit of weirdness around for the 2 versus 6 bit pointers in Vassam. So I guess. Oh shit! There are bindings in the repository. Alright. Yeah, you know what? Let's port this short example I have into Odin. And I think, yeah, I mean, this function as well is pretty short. Clay string text clone the some stuff. Font, Raylib fonts, draw text. We could yeah, you know what? Let's do this. So let's start up by getting Odin into my VSL. And git clone. So Odin is a language made by someone named Bill, Ginger Bill, and it's very similar to C in all respects. He just added some very nice to have features. I guess, yeah. Slices is a big one. Handling arrays and slices is so much nicer than using whatever in C. I guess we also have generics or whatever templates if you have used those before. Those are very nice. Comp time in Odin. Pattern recognition is also very nice to have. So let's see, we should just be able to run the build Odin dot. No LLVM config found. Set LLVM config to proceed. What does this mean? Oh, do we need to install? What's this? What is this? LLVM config. How do I get this? By installing LLVM. So should I just install LLVM? So the command install LLVM package, which is probably a special package which uses the most up-to-date LLVM available in your standard repositories. In your case that was 2.9, same idea applies to Clang, blah blah blah. I guess let's just try to get the latest version of LLVM. Whoa, that's 730 megabytes. Yeah, so I guess, yeah, LLVM is big. And it takes ages to compile. I've done that once before, a couple of months ago. And compiling LLVM on your own takes half an hour or something. Super big. So let's try build Odin now. No Clang ++ command, set cxx to proceed. Have I not installed Clang? Maybe I haven't installed Clang. Actually, maybe I just installed Clang D in Visual Studio Code. Yeah. Okay, so let's see if it manages to compile Odin. Yeah, we're good, I think. So we should have an Odin executable. Yeah. So now we just have to add that to our path, to this file. Here we have to export path, and path would be home/dev dev/Odin / no, maybe just this. No, yes, because dev Odin home /dev/Odin. Yeah. Okay, so let's exit and enter, and now Odin check. No, what can we do? Odin report version. Yeah, so we are running the version 2024 from December. Okay, so now we have Odin, so we can go back, and we have, where are we here? No, where the fuck, where are we? Oh, I guess make directory, let's name it class book valve Odin. Let's cd into class book valve Odin and create a main.odin file. Right? Yeah. I guess let's try this. Yeah, we don't have the Odin extension, VS Code. Odin language servers client could create a connection to server. I think Odin OLS is something. Yeah, so we need OLS as well. So let's clone OLS, which is the Odin language server. It's just nice to have. I can't live without my auto completion and jump to definitions. Alright, so we have OLS here. And once again, oh, I'm getting a call. Alright, let's continue. Oh shit, yeah. So OLS. Yeah, OLS. Now we have OLS installed. Let's reload window. So it's trying to, yeah, no, this is super wrong. How do we change that path? Yeah. /home /David /dev /OLS. Yeah, so now it's working. How do you use Odin? I have forgotten. No, we need to import core format, and we can do format print line no Odin, and then we can do Odin run, right? No, Odin, yeah, Odin run. Yeah. So there we have a running Odin program. It's the first step to getting this to work. So now we have the bindings. Download the clay Odin directory and copy it to your project. Yeah, okay, so let's copy clay Odin to this directory. Yeah, and of course we need to do recursive. So now we have the bindings. There's a package clay. So this will detect our operating system, and it will import the static library which already has been built for us. And then I guess this is just the, yeah. So creating bindings from C to Odin is relatively simple because they share the same ABI, I think. That's what you call it. So now we should just import clay as clay Odin. Import clay Odin. let's see how this works now. So let's put this to the side. So min memory size clay dot memory size. So very similar to the C implementation. Create arena with capacity and memory. Clay initialize the arena. Yeah, so this documentation is already out of date, of course. Layout, no, just dimensions. And dimensions to width and height. How do you do this in Odin? I don't actually know. I don't know at all. Odin language. Let's do dark mode and select structure. How do you initialize a structure? Let's do width 800, height 600. Height would be height. Actually, can we do just? Yeah, we can. But if I were to pass in another number here, then it complains because too many values in structure literal. Okay. But you can't do with dot with. No. Right? No, you can't do with. Oh, you can. So I guess this will implicitly convert this integer to a float, because width is supposed to be a float. Okay. So this is we could import like Raylib. Or we could, if we go into, I guess, renderers, they have a Raylib renderer, which is in C. So I'm thinking about how we could implement the clay renderer for Raylib in Odin. I mean, it's not super big. Yeah, I mean, let's give this a try. Renderer.odin. Package main, and here we can import vendor Raylib and import clay as clay Odin. And we have some functions. We have the clay rectangle to Raylib rectangle, clay rectangle to Raylib rectangle. So let's make this a function. We shall return an R rectangle. Width should be, this is a clay rectangle. This rectangle. No, so so this is never used. So this one is used a lot, so let's implement that. Clay color to Raylib color. Takes in a clay.color and spits out a r.color. Return r.color. For U8s is for floats. to convert float to U8. How do you do conversions in Odin again? Okay. All right. Moving on. Yeah, so it's the name colon U32, and then it's the name colon r.font, and then this is declared as a global. As a global variable of type Raylib font. I don't know how to do this. Array. Fixed size array. So the type is after the brackets. So 8 Raylib fonts. And then we have camera, Raylib camera. Then we have enum, custom element type. I don't know if this is necessary. Is this in used? Yeah, it's kind of used. Okay, so let's do this. And put the Odin documentation on my left screen. So we have custom layout element type is an enum. Custom. I'm not a big fan of all caps overall. I don't get the point of screaming. I know I used here, but actually let's change that. Let's see. And then we have another struct called custom layout element 3D model struct model, which that's a Raylib thing. Okay. And then we have a float scale. And then we have a position for vector 3, and then we have a rotation matrix and another struct called custom layout element, which is another struct. It is either a custom layout element type or it's a union. How do you do unions? How to do union? Oh wait, so maybe we do this. Yeah. Type or model. And that's it. Then we have the functions. And it looks like there's a couple of functions. Shouldn't be too hard to do this in Odin. So we have a function that returns a ray, gets screen to world point with said distance, which, yeah, so you can do perspective. Interesting. Okay. So this we can implement. Get screen to world points with said distance. Position, call vector 2, camera, screen, width, integer, and screen height, and returns an r.ray. Array, zero initialized, return ray, and then we do all the math. I guess we can try to copy all of this, but we have to rewrite this, of course. So this will be F32, and we don't do that, we don't do that, we don't do that, and we do F32 screen width, and we do F32 screen height. Don't do that, don't do that. Here we do vector 3. Same here, we do matrix E. Or sorry, what? Matrix. can't do this. Camera projection dot perspective, or it's orthographic. So r dot camera projection dot orthographic. And the same here, right? Wait, we have to do r dot here. Same here, r dot, and this is undefined. We need degrees to rad. I think Odin has a pretty massive or well implemented core math library, which I suspect will have some sort of degree per rad. I guess 2 degrees. We want 2 radians. So 2 radians. So we want the FOV passed into so this has F and FO is A32. Cool. And then double precision, I guess. But double precision is just F32. Okay. I'm not sure if we should actually use F32 up here. Because Victor, yeah, it's all F32. So we I'm not sure what float is in this is too many arguments, right? Near plane, far plane, aspect, FOV, aspect. This is the aspect, and then near plane, far plane. Oh, we have something wrong with our here. Yeah. Here we do. Oh, fuck. How do we? Oh, whatever. F32. Why isn't screen width passed in as an F32? We should change that, perhaps, maybe, I don't know. No, r.vector free. r.vector free. And we don't have to do this casting thing. We don't have to do that. 1 0 0 0. Pass in the matrix. Yeah. Same here. No. Yes, I think Odin has operator overloading. I think, right? Operator. I'm not sure how. Actually, I think since the vector free is Odin, an Odin vector or Odin array, and Odin has support for subtracting arrays element wise, using just operator between them. That's why they prefer to use this instead of r.subtract vector free. Yeah, so that's it for that. Then we have this measure calls, measure text, measure calls 0. I wonder why this is here. Maybe a debug artifact. Yeah, we'll skip that for now. So the measure text function, clay text element config pointer clay string. I wonder what the Odin implementation of clay uses instead of string. I guess just string, the built-in string, looks like. Yeah, it looks like there is a string struct, and then there is a conversion from the built-in string to string, and this is not used that much, but the text macro or import takes a string, which then converts it to a string here, and this is the C function. Yeah, so we can just use normal Odin strings then. Because here we just, what do we do here? Oh, what a mess. Yeah. Cool. Okay, so this function returns clay dimensions. Yeah. And it's called Raylib measure text. And it's a procedure that takes in this text and then a pointer to clay text element config and returns a clay.dimensions. Then there is text size, dimensions, return text size. Max text. Yeah, so this is a pretty standard algorithm for finding the max size. We just loop for everything and check. Or yeah, kind of looks like that. I don't know. Whatever. Let's just run through the motions. Config dot text. No, font size. Font size is a U16 here. Alright. We could also just do this, right? No. We have to tell it. Font to use will be a R font, and it will be Raylib fonts. Raylib fonts config.font ID. Scale factor will be config font size divided by float font to use base size. Oh, sorry, I forgot to. And then we loop through the text character by character. So let's do the exact same. For I is 0, while I is less than length of text. There's no plus plus operator in Odin, which is fine. I mean, it's a confusing operator sometimes, unnecessarily confusing. So if text, if we hit a new line character, the max text width will be the max value of max text width or the current line's text width. We reset the width and we continue. Otherwise we get the index. Yes, this is the ASCII. Wait. ASCII point. Right. How do you convert UTF-8 to ASCII? Do you just do -42? Yeah, I don't know. I'm not sure about this. Maybe someone in the comments, if you are still watching, can explain this part. Yeah, I don't really get this part. Let's just follow whatever they're doing here. If font to use, okay, let's font to use at dot glyphs at index is not equal to 0. Line text width is equal to line text width plus font to use glyphs index dot advance x. Okay, so C int is an I32. Alright. Else. Line text width is equal to line text width plus font to use dot regs index dot width plus font to use glyphs index dot offset x. Yeah, so this I feel a little bit weird about what we use here. Actually, let's keep these as F32s. That way we do not convert here, but we do convert here. So we keep the precision. We keep the floating point precision, because I guess the width here can be a decimal point. And after the loop we do another max between max text width and line text width, and then we do text size is dot width is equal to max text width times scale factor, and text size dot height is equal to text height. Alright, moving on to clay Raylib initialize function. Clay Raylib initialize procedure. It takes in a width and a height and a title and a unsigned int flags. Bitset, yeah, okay. I was thinking that this should be a bitset in Odin, actually. And then we do r.init window width and height and title. Yeah. How do you convert string to C string? The Odin string type stores the pointer to the data and the length of the string. C string is used to interface with foreign libraries. So how do we Odin language convert string to C string? The C string is a type, it's a C style string value, which is 0 terminated. It is equivalent to char const. Yeah, const char. Its primary purpose is for easy interfacing with C. A C string is easily converted to an Odin string. However, to convert a string to a C string, it requires allocations if the value is not constant. It is not constant indeed. I mean, if we just take in C string here and we let the caller allocate a string, which this will work if we were to call this function and you pass in some numbers and then you pass in like hey, this would work, I think. Let's see. Yeah, 0. How do you do these distinct bits? How do you how do you do bit sets? Yeah, so this will work because this is a constant string. But if we were to do title here and then pass this in, this is no longer constant. So we would need to make a C string, or maybe not. I'm not sure how you would do this. That's not really relevant. So now we have the big function left. Proc, which takes in render commands from clay.render command array. Yeah, I know this. I know. Okay, whatever. Let's. What is this type? Oh, okay, makes sense. So this argument will be a clay array of type clay render command. And there's no output, right? It's a void. It's a void. Alright, so we just loop through. For I equals 0 while I is less than render commands dot length I plus equals 1. Yeah. How long are we? We have been going for an hour and 7 minutes. Yeah, I think we will. I want to finish this up and see if it works. Prefer matrix 1. All right, matrix 1. I really want to see if this will work. And if there's any problem, we will fix it in a later video. So render command will be a clay render command pointer. Render command. So bounding box, clay.bounding box is render command dot bounding box, and then we switch the command type. How do you do switches in Odin? God, I'm such a noob. Yeah, so you just, it's a normal switch, render command, not command type. Yeah. We can do the partial default, maybe. this will be a partial switch. And then we do clear dot render command type dot text. Raylib uses standard C string, so it isn't compatible with cheap slices. We need to clone the string and append null terminator. This is not a problem for us, I think, because clay string will be render command dot text. Yep, I'm done. So let's extract the font to use. Will be a r.font from Raylib fonts at render command config dot text element config dot font id dot font. Font to use. Yeah, so this is a C string. So now we have to actually fix this or learn how to do this. So I'm looking at the examples that the Odin language has, and I'm looking for an example where they create a C string from something that is not constant, I guess. This is it. This is all they have. I'm also looking at this, so let's look at allocation. Here's here if possible type correction, including whether to copy or alias. This support understands it. Odin gives you the possibility to keep allocations to a low degree. If some cases are missing, please let us know. Legend copy. Get a fresh allocated copy of the from date. So what we want to do here is use the temp allocator. I think. And after the temp we want to do context. This is the wrong file. We want to do context.temp. We want to clear context.temp allocator. Free. All. So somehow we want to use the temp allocator to sorry, this music sucks. Put on some normal music. I guess what we want to do is allocate length of text u8. We have a char array, chars. I'm not sure. I'm this, right? And then we copy destination would be T and copy from text.chars. I think I'm close, right? I mean, someone has done this before, right? We should be able to find something about this Odin language C string. God damn, this is a long line. So I'm feeling kind of dumb because in this example here they have a he has a short to convert a string to a C string, which is what we want to do, right? Because we have text. Maybe this works. Yeah, we'll see. Alright. Next case. Render command type. Image. Image is image texture. Text array texture type. Render command config image data. Cannot cast image as texture from raw pointer. mean, they're lying. They are lying right now. We are able to cast raw pointer. Yeah, here. Here's a function. Okay, so the clay string converted to Odin string, and then we use the clone to C string with the temp allocator for both, and we always clean the temp allocator after each render loop. I'm happy with that. So back to this problem. So we need to convert to a texture to D. But here they do some kind of dereferencing magic and deref. Oh, this is here. They operate the difference the pointer of the underlying value. Yeah, this is not working at all. Cannot dereference or texture to the of type texture. Cannot cast as texture from raw. How the fuck do you work with raw pointers then? Exception of this, all pointer types can automatically convert to raw pointer, and untyped constants can be converted to a type. What if we difference the pointer here? No, that's syntax. Oh, I feel so. You have to do this somewhere in the clay code, right? No. Maybe in the Raylib code. Let me. I'm trying to thinking about asking this question in the Odin Discord. I'm not sure how to ask it. I mean, the question is, I have a raw pointer from the clay bindings, from the Raylib, that I know is convertible to a texture type. So how do I cannot cast as texture from raw pointer? The question is why. Okay, let's try to formulate this question. Casting raw pointer to type. I'm using a C library. It gives me a raw pointer that I know will be castable to a Raylib texture to the. I'm trying to do this. Oh, how do I format code? Let's remove the context. Image data is of type raw pointer. Let's see if someone answers this post. Yeah, so I think we're going to end this right here for now, and we will continue in the next session, perhaps finishing this function off. Because from reading this, I don't think there's a lot of challenges left if we just figure out this. Custom data is also probably a raw pointer. Yeah, so begin scissor mode, end scissor mode is super easy. Rectangle will be super easy. Yeah, so I definitely think this is the biggest problem left before we can finish this off. Yeah. Alright. Thank you.